All right. Hello, good evening, everyone. Good evening to another wonderful, interesting talk in our module Emerging Fields. Today, I welcome Peter Weiss. Thank you for coming. Peter Weiss is the founder and president of Spartan Space. And Spartan Space is an innovative startup that develops smart habitats for space, outer space, and for underwater. The company is headquartered in France and it was created in 2021. Today, it is managed by a group of senior space and underwater engineers, astronauts, and also architects. Peter Weiss himself has more than 20 years of experience in the maritime and space sector. He worked at DLR in Germany, MIT in the US, Cybernetix in France, and the Hong Kong Polytechnic University as the director of the Space Department, and he was a company board member of a grant company that's called COMEX in France. And he was also the co-founder and president until 2016 of POWERSEA. POWERSEA is a startup company for the development of underwater connectors for marine renewables. And I'm happy to have you here, Peter, to talk about a little bit about your new startup, or not new startup, about Spartan Space and about the topic deployable structures and lunar prototypes. Thank you very much. Welcome.
Okay, thank you very much, Sandra. So I share my screen maybe, that I can show you some of the pictures and things that we are doing. Please let me know if you can see my screen.
It works.
Can you see my screen?
Yes, wonderful.
Okay. I hope my internet connection is good. As you can see, I'm not at home. I'm sitting in a nice hotel in Lille, but I hope this will work. You just let me know if you can't understand something, or if you have questions, feel free to ask me right away. I think anyhow there will be a time for question at the end of this presentation. Yeah, so Sandra already presented me. I think I won't add a lot to that. Maybe just to say I'm from education. I'm a roboticist. I made a PhD in space robotics in Hong Kong and was working long time in space robotics and also in underwater robotics. So always swimming between those two fields, because there are lots of synergies that can be used from maritime sector to the space sector and the other way around. Albeit the fact I'm roboticist from education, I'm a big fan of human spaceflight, because I think it's important that people are going to space, and that will then directly lead also to my presentation here. So I'm giving a talk about extreme architecture and systems, deployable systems that we are developing. Before starting that, I would like to a little bit talk a little bit about architecture in general. I will also present a little shortly our company and explain the context of future space exploration. I think you have seen that already quite a lot in previous presentations, but I think it's important to remind some of the elements just to understand why we are doing this and what we want to do, and also what's the role of our small company, our startup, in this adventure here. So for starting, I added this question here: what is the purpose of architecture? That was quick. I don't know if you know that place. It's quite known, hopefully normally, in Turkey. I think it's one of the oldest cities that we know today, or that is remaining. It's quite an interesting place because that was the switching point between civilization hunters and getting farmers and settled. I think this image now might be a little bit, people in the future might look back to our time here. This is the system that civilizations that leave Earth orbit and go further beyond. At least that's what I'm hoping. That's what's driving me every day. Um, and in the future, yeah, we'll be back to this. And to come back to the question of is obvious.
I have lost you. Can you hear Peter? Peter? Okay. We have a bad connection.
Yeah. Is it?
Let's try again, but maybe turn your camera off.
Yep. Okay. Sure.
And
I'll do this right away.
me too.
Did you at least understand what I'm saying, or was it not good?
I didn't understand the last 2 minutes.
Okay. Okay. Well, let's try again. Let's try again. So, can you see my screen?
Yes.
Okay. So I'm not sure where it broke, but what I said is that I believe that we live in a time where in the future people might look back and say, okay, this was the moment where our civilization left planet Earth and went to other celestial bodies, leaving them marked there, like this wonderful old ruin here in Turkey. And obviously, architecture is a vector for this. It's a vector for culture. I will not go in details, but I think everybody knows the two examples that I'm showing here, and everybody knows what kind of image these architectural things are bringing through history. So architecture is enormously important, of course. So I'm asked to give a speech about architecture for extreme environments. There are several that can be named here. We work almost on most of them. So polar stations like Concordia here, the Concordia station in Antarctica. High altitude habitats, that's something that's very interesting at the moment. There are several missions on the blueprint, if I might say, to bring people into high altitude. It's not space, it's in between space and Earth, in 20 kilometers, for example, but a very space-like environment. Then desert habitats like the Ski habitat that we were building in the frame of our European project some years ago. And then, of course, space and underwater habitats like ISS, and that everybody knows here. And I will talk a lot about space habitats, so I'm not talking more about it here. And underwater habitats like the Aquarius base in Florida, that, by the way, is also used by European Space Agency and NASA for tests of future missions. Okay, I hope you can read what's written on the top line here. I think we need new Jules Verne's, and that's mainly to you as architect. I'm directing that. But we also need new Gustav Eiffels. That means often you see concepts that are developed, that are brought forward, that are fantastic, looking very nicely, but the problem is they are not feasible, and that is very important. And this is something I really would like to underline in my presentation here. When you do something, especially if you're working on architecture for extreme environments, you need to make sure it's feasible what you are proposing, because actually by proposing non-feasible projects, it's not forbidden, of course. It's something one can do, but it needs to be clearly underlined that yeah, it's leaving a little bit the science and going into the fiction section, because by doing this, you might give a wrong image of what can be done. So feasibility is depending on many factors. I mentioned some of here, obviously the technology or the technology levelness, readiness, the TLR that you might often hear, or the maturity of a technology. Do we have the technology to do something? For example, I've given an example of a Mars habitat, or I've even seen habitat on Europa or things like that. One really needs to ask, do we have the technology today to go there? Budget, obviously, is another thing. Here is this very nice example of the ESA moon village that you can see here on the bottom picture. The question of something like that, can it be? Do we have the money for building something like that? Here also is the question of the technology, but already the money, is there budget available for building a city on the lunar surface? I believe yes, it might come, but not in a very short term. It will be in many decades. So it's a question of timeline. Also a question of concept of operation, CONOPS. For example, just to give an example, often you see proposals of independent greenhouses on the lunar surface. Again, I think this is something that will be coming in the future. We will see greenhouses and population on the lunar surface. Maybe not my lifetime, maybe yours, but right now it does not fit in the concepts of operations in CONOPS. It's not. We'll talk about Artemis more in detail afterwards, but right now nobody foresees to grow any tomatoes on the lunar surface in order to be harvested by the astronauts. This is not part of these operations that are foreseen. And then geopolitics, of course, with all these actors that are coming in. So basic message is really, when you do something and you claim that this is a concept that is feasible, you have to check this kind of elements. And this is what we are trying to do with our concepts, and hopefully successfully. So Spartan Space, as Sandro already presented, is a young company. We are approaching our 3rd anniversary. We are one of the startups in France in the new space sector, and our objective is to work on habitation system for extreme environments. Might it be space? Might it be underwater? This is a little bit based on the curriculum of myself and my colleagues, that we worked a lot in underwater and space. So we are addressing this. This shows the composition of the company. So there's an operational team which is working together since already quite some time, already before creating Spartan Space. We have advisors coming from either being astronauts, being architects like Jacques and Barbara, or astronauts like Jean-François. We also had Jean-Jacques Favier as our founding member. Unfortunately, he passed away this year. So yeah, we really search to be a multicultural and team with different capacities and expertise in order to be able to do what we want to do. So we work on habitats for extreme environments, but also system studies, which somehow is part of it, of course, and mission simulation and training. This is not only because we did that a lot in our past, it's also very interesting and important for developing, if I might say, the habitats here on the top level. Just to give an overview of some of the examples and projects we are working on. One I will be talking a lot about is EuroHub, lunar habitat. This is one of the big projects we are doing right now. We worked with Airbus and Liquify on a commercial orbital station, also based on an inflatable, since there are many concepts now on using orbital stations as a replacement of ISS, or for the future after ISS. But as I said, we also work on underwater systems like the subsea city here by Jacques Rougerie, or Bio-Odysseus by the French explorer Alban Michon. The system here is supposed to be installed offshore Greenland. Basically, Albon wants to stay 6 months under the ice, and Spartan Space is working on the design of that thing and the architecture. In terms of system studies, very quick only, we are somehow very much expert on when it comes to lunar surface. So we build right now for European Space Agency a lunar surface simulator, which is that machine that you can see here. That's a high vacuum a thermal vacuum chamber with lunar regolith simulant inside, lunar dust. So what you call a dusty or a dirty vacuum chamber, will be one of the biggest in the world and the biggest in Europe. But we also work on radiation protection, docking system, things like that. We are developing. And on the other side, also spacesuit systems. That's, by the way, the reason why I'm sitting in a hotel right now, here in Lille. For me, a spacesuit is an inflatable habitat, and there are several projects ongoing for spacesuit development, where we are part of, and that's obviously very important for European sovereignty in human spaceflight. And then mission simulation, just to close that quickly, we work right now for Thales Alenia Space in Italy on iHub. That's this European module here in the middle of the new space station gateway, where we actually develop an ergonomic mock-up that can be used for tests. And we have done similar items in the past. We have done tests with EuroHub. I'll come back to that later. And also mock-ups like you can see here. So this is very quickly about Spartan Space. One of our projects is that thing that you saw already several times, EuroHub, which is an inflatable lunar habitat. And before talking about that and why we came up with that concept, I'd like to give an overview on the context of space exploration. As I said at the beginning, I think we are entering quite an exciting new era here, with humanity going to the moon and beyond. So often there's this discussion, moon or Mars. You might have heard about that. Most probably you have your own opinion. Basically, there are two possibilities. Either we go first to the moon and then to Mars, or we go directly to Mars. And I will be extremely clear about that and give you my point of view. I think the only way to do it right now, obviously, is going to the moon and then to Mars. I see that sometimes in some even agency communications, where it's said, yeah, we should go to Mars first, or Mars is priority. One has to be very clear. Right now, we do not have the technology nor the budget sending human beings to Mars. And even if you would have that, most probably it would end up in planting a flag, most probably again a US flag, or maybe Chinese, and then not going back for 60 years. So this has nothing to do with sustainable space exploration. On the other hand, going to the lunar surface is extremely interesting. The moon is not just a step towards the solar system, it's the step towards the solar system for us here on planet Earth, because it provides resources and a playground that is super important. So that is really an important step, my opinion. There might be other people who don't share that. Along with that, of course, there's at least on the US side is the Artemis program. I'll talk a little bit about the Chinese later. Humanity's return to the moon. You might have seen that already some months ago. Artemis 1, without anybody on board, was going back to the moon or around the moon. It looks all very, very simple. I mean, if you might have seen graphics like that already. Yeah, just an orbit around the moon and going back. I put that here into a scale. Just try to get that away. No, not yet. You see the whole thing, and just to remind, the moon is around 380,000 kilometers away from Earth. This is 1,000 times the distance that ISS is flying above us right now. And here you see it on scale. I'm not sure you can see the moon here. Hopefully you can see my cursor and Earth here. And I think there are 31 Earths in between. So this gives an impression about the complexity of missions like that. It's not just it's not just like this. It's a real complex endeavor, bringing humans or robots to the lunar surface. Mars is then, of course, even more far away. Yeah. Just to illustrate, if you drive in 80 kilometer per hour, it takes you 6.5 months of travel. So that will be the next step, and you already saw this Lunar Gateway. This will be a very exciting station. There's a lot of discussion about, does it make sense to bring something in the lunar orbit? I think yes, because it will be a playground for missions far away, and it's a nice, interesting outpost in lunar near the lunar surface, which is not at all the same like ISS today. So this graphic is actually not very new. There were some changes, but it shows a little bit the architecture of the gateway. So it's a nice mixture between US and European elements. Then there are also Japanese elements from JAXA and Canadian elements. I said it's quite an old picture because I think the Russian airlock disappeared. They're right now discussing about building it by another nation, the airlock. So there's contribution from two European. There are two European modules on Gateway. There's the iHub that I was already mentioning before, which is the habitation module that is right now under construction in Thales Alenia Space Turin, in Italy. And the second one is the ESPRIT module here, which also provides some kind of habitation volume. I have some sound in behind. Somebody is not mute, I think. Super.
Yeah.
Thank you very much. So ESPRIT, and it's also about communication, that system. It's also built by Thales Alenia Space in France, and the pressurized module will be built in Italy too. And then going to the surface, and here this is super important. How will we go to the surface here in Europe? And by the way, of course, I'm expressing a lot of the European point of view here. In the US or China or India, that might be look a little bit elsewise. But here in Europe, we are working on the Argonaut, the EL3, European Large Logistic Lander. Here's another view of that. It will be some kind of medium-sized robotic lander, so it's landing robotically. There's nobody on board. It's like a cargo vehicle that allows to bring elements to the lunar surface. Around 1.5 to 2 tons of mass. And then obviously the return of human astronauts in the frame of Artemis. You might have seen that schema here that shows the plan of the different missions. Much too complicated to me. I tried to make it a little bit more simple. So Artemis on 1 with the flight that we saw this year. Then Artemis 2 will be coming in 2024 with crew on board inside Orion. Artemis 3 is supposed to land on the surface for 6.5 days with 2 astronauts. There's discussion now ongoing that this might also be an orbital mission, but I don't know. It depends. Then Artemis 4 will be bringing IHAB on the gateway. Artemis 5 again on the surface with a number of astronauts not fixed yet. For the duration not set yet. They will use the Lunar Terrain Vehicle, LTV, a little rover that allows them to go a little bit further. And Artemis 6, same configuration. Don't know how many astronauts and how long they will stay. And then there's Artemis 7, 8, and 9. And that's what I call the Artemis horizon. That means beyond Artemis 6, for instance, to my knowledge, it's not financed. So there is a risk that Artemis is stopping at that year, 2030, which is not so far away. It's we are talking about 7 years. Okay. And actually, in 2 or 3 years, we might see astronauts on the lunar surface. So this is very short, and here again, European perspective. Europe really has to start moving and deciding what will we be bringing into that game, in order to be part of it. Yeah, do you have a question? No, okay. Because right now it's only American and yeah, here's a Canadian. So I'm not 100% certain we'll see a European astronaut on the lunar surface in the frame of what I called here the Artemis horizon. So the Artemis 3 landing sites, you might have seen that. It's all around the south pole of the moon. Why? Because it's an extremely interesting region, extremely important region due to the resources. And there's a real difference between Apollo and Artemis, if I might say. While Apollo was targeting various different sites quite far away, I think the closest one are around 180 kilometers, one apart from each other. Artemis missions will be mostly located all around the South Pole, and that has a major impact also from an architecture point of view, because that means that equipment or infrastructure that is built there or set up there can be used by several missions, and this is quite a change in the game, if I might say. Apollo was primarily based on geologic exploration, while in Artemis, it's claimed to be a sustainable presence on the lunar surface as a stepping stone to go further. And as I said before, well, the Artemis horizon is not so far away. When I look at the current missions, I personally still have a little bit of problem to see the sustainable presence there. Mainly it needs to come with elements that can be used by several missions, and then later on again. Yeah, and then of course one last and big difference between Apollo and Artemis, it's Apollo was a US only missions, while Artemis is clearly open to international cooperation. There's obviously this this new space race. I mean, you can call it as you want. For me, it's exactly the same like humanity has seen before, between Artemis and the Chinese. This picture was published here in St. Petersburg 2 years ago, I think, or 3 years, where it was still a cooperation, a very strong cooperation between the Chinese Space Agency and Roscosmos. Today, I have the feeling, given the current geopolitical situation, it's more the Chinese Space Agency that is driving this. And for me personally, this is very good because it encourages the players to speed up, to be fast, to be efficient, in order, if I might say, to be the first on the lunar surface. That's why I said we will see in some years American astronauts on the surface. I'm 100% certain about that, unless there's a major impact or a major event happening. We will see them on the surface. There's no question about this. So what is Europe? What can Europe bring in there? And slowly I'm approaching my subject, if I might say. I think that Europe should bring into this whole game what I call lunar logistics, which might then lead to a lunar economy. Actually, I think that Europe could work with the US in order to make Artemis sustainable, meaning that we provide the elements that are there in order to make it sustainable. Might it be communication or navigation with the moonlight? That's an ongoing project with ESA. The lander that I already presented, the EL3, there are also others like the Nix from the exploration company. Rovers, mobility, rovers that drive around and bring equipment or products or gases or energy from one point to another. There's one project ongoing, it's called EMMS. There are many others, of course. EMMS is an ESA project. Power generation. The South Pole is a very interesting point to create solar power. And there's a project called European Charging Station for the Moon, ECSM, that can be positioned on a lunar surface and be some kind of power plant. Secondary habitats like EuroHub, I will come to that. Why is that called secondary habitat? In situ resource utilization, ISRU with Euro2Moon, and then maybe later habitation on long duration, so bigger complexes of habitats. So I think this is what Europe could bring in, because the US right now is running to be the first back on the moon. And so all the efforts are going into what they call boot on the moon, or the first human being back on the lunar surface. And Europe could provide, to my point of view, this kind of auxiliary equipment, but it is very important items. And here comes then EuroHub. So it's a secondary habitat. What does that mean? That means basically it's a habitat that is landed on the lunar surface on the South Pole. It's landed without crew on board. It's a robotically landed system. Will be setting up and waiting there for astronauts to come. It can be used like a base camp, like if you go to Mount Everest altitude. And this is exactly the same. What you see here on the chart. I hope you can hear me, because I just had a message about the internet connection. So what you can see here on the chart is basically so it's the South Pole, the lunar South Pole, and you have several zones that are marked. There are zones which are marked in blue, and these are safe landing sites. These are sites which are rather flat, that can be used to provide safe landing to human crewed systems. But the sites of interest are the yellow spots and the red spots. The red spots are the bottom of the craters where we expect water in the form of ice, because they are permanently shadowed, PSR. And to my extent, even maybe more interesting are sites of high illumination, these yellow spots, where there is almost always solar light, because the big problem on the lunar surface is the lunar night, where temperatures are dropping and you can't produce energy. Here on these yellow spots, and there are not so many, you can produce almost permanently energy. Now, the idea of the secondary habitat is, since it's landed robotically, you can land it, if I might say, anywhere you want. You can go on more riskier places than with the human landing system. An astronaut can go away from its landing system, from its landing rocket, if I might say, 10 kilometers by a rover, unpressurized rover, 2 kilometers by foot. So you have a radius of 10 kilometers here, and you see basically when you land here on these blue spots, they cannot reach these spots of interest. They're too far away. And here comes the secondary habitat. The secondary habitat is positioned and allows the astronaut or the crew to go further away, because if there's a problem, technically they can go beyond 10 kilometers, but if there's a problem, they can go back to this safe haven, to this refuge, if I might say. So it's a habitat that has to be built as a payload to a robotic lander. And we used at the first instance the EL3, the Argonaut from ESA. We also, of course, discussing with other entities if there's other possibilities, but we need something around this with this kind of capacity. As I said, around 1.5 to 2 tons. And here I come back to what I said at the beginning. You often see very, very nice projects and designs of lunar habitats, big domes with a lot of different elements and things like that. Unless you cannot explain to me how that thing is brought to the lunar surface, it does not work for me. If you cannot tell me how your equipment will be brought there, it's unfeasible for me. And that's why we are really hunting this aspect. Our habitat, this EuroHub thing here, needs to be a payload. It needs to fit into the capacities of the payload of a robotic lander. If I don't respect that criteria, my thing is unfeasible. So that's a little video that shows the principle of that thing. So basically, EuroHub is landing robotically without anybody aboard, sometime before the mission, sometime before the astronauts arrive. And the thing is opening up and getting inflated. And at some point there's an airlock coming out. So that's our airlock. This was the first architecture. Architecture changed a little bit later. But that was the first concept that we were proposing. And then it waits. It's there, sitting on its spot. It doesn't move. It's permanently there. It's there's no concept of moving it around. And then the astronauts can driving to this habitat and use it as a base camp in order to go further. This is basically the idea of this secondary habitat concept. And by doing so, you can extend the range of intervention by a human crew quite significantly. Obviously, you could imagine in the future that there are several of these kind of outposts being positioned on the lunar surface. For us, it would be super fantastic. But that's the basic idea behind this this habitation system. It can also serve as a rally point in order to, for example, robotic vehicles bringing samples to this place here, where they can then be later collected by a human crew. So we are also working on this kind of concept. And it would be a real first permanent outpost or a permanent house on another terrestrial body. So that resumes again the idea. Basically, if you have a lunar lander, your astronaut can go 10 kilometers by a pressurized rover. There's a little bit of discussion about that figure, but it's something like this. By foot, it's 2 kilometers. If it's a pressurized rover, it's longer. And technically, they can go further. That's not a question. It's a question is only in case of a problem, they need to be able to return. And basically, if you position this secondary habitat in a distance of 20 kilometers, then your astronauts can go 30 kilometers away. And that brings quite a lot of interesting scenarios for lunar surface exploration on the South Pole, where you can imagine this habitats being positioned at several sites. And being used as outpost. Oops. So we built our first prototype of that thing. It's not flight hardware at all. Was not supposed to be, but we wanted it to be in real scale. That was right at the beginning of the creation of our company. So we had the chance to exhibit it in Dubai at the IAC, also in the French pavilion of the Universal Exposition. Then later we did analog trials in Abu Dhabi, since it was already there. We are playing a little bit around with that. So it's a pressurized system, but yeah, it was supposed to that we equip it further with live support and things like that. We did then tests in Luxembourg. This was in Luxembourg with the European Space Agency. Also playing around with robotic refueling and robotic servicing of this habitat. It's very nice. And that's what I said before. Simulation is extremely important here. It helps a lot to learn how about your system is working or not working. And in Luxembourg, they built this fantastic terrain. I just show you a video what they did. This was a little more than 1 year ago. Inside a big stadium, they built a lunar terrain where they could play around with robots. And obviously, there's no vacuum. Obviously, it was not real lunar surface dust. But at least in terms of light, in terms of terrain, it was quite nice. And we were thus testing with EuroHub different strategies to resupply our habitat with oxygen and gases and things that we need. We did this in the frame of something that's called Euro to Moon. And here's a video that shows a little more what that's about. Basically, we do not want to build a throwaway habitat. It's important that our habitat can serve several missions. And in order to serve several missions, we need to resupply it at least with oxygen. And there's different ways doing that. Either you say, okay, each crew has to come with their own oxygen and they fill it up, or we do it robotically. There's also a regenerative fuel cell inside there. So actually what we did here is a robotic resupply using a power regolith plant here that you see from Airbus that is extracting oxygen from regolith, from the lunar dust, and then an rover from iSpace that is going to the habitat, not so far away in this case here, to dock to it and resupply it with oxygen. And this oxygen could be used then also potentially to drive not only the life support system, but also a fuel cell, which you can see here on the pictures just below. So it was a little docking station where the robot drove and had to dock. And obviously, in this case, it was not a real connection. It was just, if I might say, a robotic ergonomic test. Right now, we are working on a refueling system that can do this kind of purpose. So real transfer of gases, fluids, or power or data. So the robot is approaching and then ultimately docking. That's it. Transferring the gases then to this fuel station fuel cell, sorry, that we have that we have implemented. Fuel cell by Air Liquide. Because actually the power supply or the power management is quite interesting here. When you build a life support system for a habitat in extreme environment, here there's a very elegant solution where you can potentially use different elements in a circle. Water, oxygen, hydrogen can be used by the life support system. I mean, oxygen and water is needed by the crew, of course, but it can also be used by the regenerative fuel cell. And that is what we are working on with the CEA in France and Air Liquide. And CEA is providing solar panels, flexible solar panels. But the strategy is really on working on storing the energy. It's not on producing the energy right away, but maybe producing just a very little bit, but storing it. Because, and here I come to the CONOPS, to the concept of operations, our habitat, this kind of secondary habitat, will only be used some days per year. Some days per year by a crew. So that means you have a long time to fill up your reservoir with energy, and then you burn it down very quickly. Then the crew uses it for some days, and then they go away, and then you can start up building your energy reservoir again until the next crew comes. So you don't need a lot of energy all the time. You need to store a lot of energy in order to be providing it when it's used. And that, by the way, can also lead to quite some nice terrestrial applications. As I said, on that first habitat system, we were building this prototype. It was empty inside at the beginning. Then we started working with different schools and the Arcis network in France on the internal design. So this was done by students, very nice, with different concepts, keeping in mind, of course, that the thing needs to be foldable. It's an inflatable habitat, so you have to think about that. We also work with the IRAP in France. It's a research institute about signs that could be used inside, and also different sensors that can be positioned on the surface. So the idea is that a robotic vehicle can bring samples to EuroHub, and those are then either analyzed by the astronaut during the time on the surface, or even in a teleoperated manner from Earth, which might be the more likely scenario, by the way. So as I said, in Luxembourg, we did different tests with robots playing around in offloading samples into the habitat. It's like a lift, you see. The samples are stored here and then going up into the analysis facility, which was just a mock-up in this case here. It was also going then to the European Astronaut Center, where it was presented to the high-level advisory group, HILAC, some time ago. It was also in the ministerial, unfortunately, only a small mock-up in Paris approximately 1 year ago. And since then, we are continuing working on that with Thales Alenia Space France under CNES contract. It's not called EuroHub, but as you can see, it's quite the same concept. It's called LEAS, like Lunar Integrated Shelter for Exploration. And in the frame of that, we were able to dive deeper into the subsystems. And I must say, unfortunately, we had to reduce the size of the thing quite drastically. Instead of before 7 meters of inflatable, we have a diameter of 4 meters now. But this was driven exactly what I said before, the mass. We need to make sure that the mass fits into the capacity of the landing vehicle. If we don't fit into that, then we have a problem. We can't transport it. So this is really the main driver for us is mass, volume, geometry in general. So right now this development is going its way. The purpose is that it could be brought to the lunar surface before 2030. And right now it's still feasible. We are actually following our roadmap from the phase 0 here that we have with the low fidelity mockup that was built before. Now we have a second platform that I just showed, by the way, here on the picture. Here it was at the Assemblée Nationale in France, which is the French government, if you want. And now we are attacking these different points here, like the airlock, ECLSS, the life support system, and the thermal model. So it's we are actually quite good on the road to be able to provide that to as a contribution to Artemis. Obviously, it's not as easy like this. Lunar surface, you have to respect many conditions, like extreme temperatures, vacuum, radiation, micrometeorites, and dust, and the reduced gravity, which has an impact on the architecture. And we try to implement that into EuroHub. Temperatures, just to remind you, so it's between approximately 150 degree plus and minus 200 right in the schedule. And these extremes are quite frequent. Be reminded that a lunar day, 13.5 Earth days, equal to the lunar night. That means for 13.5 Earth days, you have no light and no possibility to heat things and to produce energy. And that is why this pole region is so important, because here you can produce this. Vacuum. In lunar environment, you have around, in a cubic centimeter, you have around 80,000 atoms. Sounds a lot. This is what you have on Earth. I don't even know how you call that kind of figure, but that shows you the relation. So it's a really, really empty environment. And radiation. Radiation is, to my understanding, my thinking, one of the most problematic items that we will have there. You might say, okay, why doesn't that pose a problem on ISS? ISS is inside the magnetosphere of Earth, this blue thing here on the graphic. ISS is here inside. The moon is outside. The moon is outside. So that means we are more or less in deep space environment, like if we would go to Mars. And there is this nice graphic here that shows the radiation levels during SPE in the Apollo era. You have Apollo 7 to Apollo 17, and different levels of radiation. Some of them were fatal, like this one here, peaks. Some quite close, like Apollo 16, you can see. So it's a little bit like lottery. And right now there's no solution to protect human beings in Gateway or on the lunar surface or in Orion against the radiation. What you see here in the video is basically a test in Orion, how they try to solve that problem. Basically, what they're doing, they are burying themselves inside this kind of sarcophage with anything they can find in order to be protected. This is the only way right now. No, we saw that already twice. Up there are other solutions. One solution might be to bury a habitat below this, below the regolith. Regolith is quite a nice protecting element. Here they didn't even bury it, they 3D printed it. Why not? I think this will be coming architectures like that in the future. But coming back to what I said at the beginning, this is very complicated. Right now, we don't have the capacity nor the budget for building something like that. Nor we have the capacity to bring elements as big like shown here on the lunar surface yet. Might come later. So this is not a solution today. It might be in the future. But I'm always a little bit hurt when I see this because normal taxpayer might see a picture like that and say, yeah, why don't we build something like that? That looks much better. Today, we can't do this. We don't have the capacity. We don't have the money, and we don't have the robots to build up something like that, nor the robotic vehicle to bring what we need to build it on the lunar surface. So this is far away. Another solution might be what you see here. These are lava tubes. So these are basically tunnels created by volcanism, where you could imagine hiding a habitat inside. Then you have a little bit the same effect like here on the other image. So this is super nice, super funny. The only little bit issue is that right now, to my knowledge, on the South Pole we don't have this kind of structure. This is rather in the Mare regions. South Pole is rather highland. There are some highland lava tubes, but it's right now on the South Pole. To my knowledge, they didn't find something like that could be used. It might be existing, but right now we don't know where it is. Another nice problem is meteorites. So these are just little space debris that are flying around quite quick, 20 kilometers per second. So it would go through France in 25 seconds. This is what formed the surface on the moon that everybody knows from the photographs. Is exactly this bombardment of these materials. It's a real problem. It's not only for the materials, but also for the architecture. How do you make sure that if the astronauts are going back, they don't look like this and bring dust into the whole habitat? So we, in our concept, we have foreseen an airlock that will be used also to filter the dust and keep back dirty equipment. Typically, any suits or sampling equipment you will leave there, not to bring it back into the main habitable volume. This has to be taken into account. And then lunar gravity looks funny. It's 1/6 gravity of Earth. But that might have an impact on your architecture, basically, because very simple example, you don't need a ladder with so many steps. You can lose less steps. Or another example is you should maybe think about the height of your ceiling in the habitat. Things like that. So this has to be taken into account. As I said, the idea is making it inflatable habitat. So there are already materials that can be used for that. Obviously, most prominent example is a spacesuit, but there are even inflatable habitats already existing on ISS, like the beam here. The Bigelow Expandable Activity Module is an inflatable habitat. Here you see it inside. So that's it's quite mature technology actually. And to be honest, the idea of EuroHub was a little bit born in this project here, which we had when we were working in another company called COMEX. It's called PEXTEX. It was on identifying materials for lunar exploration, maybe also later for Mars. So materials in particular that can cope with this dust environment. It's not only orbital extravehicular activity, but also activity with dust on there. So we looked into different possibilities. We developed a methodology to test the materials, test different materials. Here you have some publications that were based on that. So the idea of the dust was really one of the main items, together with the radiation and the micromaterials. And this also leads to maybe some innovative concepts of new textiles. Here just some keywords, if I might say, like items that can be 3D printed in order to be repaired, that might be dust repelling, might think about energy harvesting by moving around maybe, and self-healing. That's very interesting. Materials that potentially can close themselves if they have been punctured by a micrometeor. So that was a little bit the idea behind EuroHub. Just to close up, while doing this, and that's very important also if you're working in this kind of startup environment, if I might say, you need to think about terrestrial spin-off applications. If I'm running around and saying to my investors, I only want to build habitats on a lunar surface, that doesn't work. They might not be so happy and might not give so much money. So you need to think about the terrestrial applications. And basically, what we are doing here is we make sure that people can live in one of the most extreme environments that we know. And for that, we need certain technologies, and some of this technology can come back to Earth. Might it be energy management? Might it be water recycling, which is a big issue in Europe right now, I think, or CO2 reduction. Here, a little bit, I need to be careful because obviously we are scrubbing the carbon dioxide out of our atmosphere in this nice little habitat. This cannot so easily be scaled up that to say, okay, this might help on a planetary scale. But at least the first ones can, to my understanding, to my thinking, really easily be implemented into normal households, and that's also very important for the architecture in your future projects. Without going into details, as I said, we are using regenerative fuel cells. By the way, sorry for the French, it's all in French, where we play around with energy and water in order to give energy, water, and oxygen to our crew. You could imagine having something quite similar on a terrestrial application. This is what we are working on right now. We also want to combine that with artificial intelligence, so that, for example, the AI can predict when energy can be produced or when energy is needed by the crew or by a normal person in a household, in relation also with the storage of the gases on the water. So coming back to Earth with what you do for extreme environment is very important, and that's what we are trying to do here with this kind of project. Okay, this was my presentation. I hope I gave you a nice overview on what we are doing.
Thank you very much, Peter. Wonderful presentation, very clear, and super interesting. Congratulations to your many projects, and some of them really look to be realized very soon.
Yeah, I hope so. I don't like paper. I like when things are getting hardware very quickly.
Wonderful. We have questions from the students. I have also some questions, but I'll let Alexander ask the first one, please.
All right, thank you. First of all, for the presentation, it was really interesting. The first thing I was wondering was, so you mentioned this 10-kilometer radius for the rover, and obviously this makes the habitats around, like, let's say between 19 and 20 kilometers, like maximum distance from the lunar lander, or like where the people are coming, yeah. So how would the debris and dust that's being like splashed into the very like non-atmospheric air, or not air, but like in the vacuum, like it's going to be transported a lot further than on Earth. Is there a problem in this like 20-kilometer radius still happening, so that there could be like dangerous debris being led there by multiple landers, like over the years, which will maybe destroy?
Yes, yeah, it's a very good question. I think I'm not an expert in that, but I think that if you are 20 kilometers away from an initial landing place, you might be quite safe from most of this kind of secondary debris. However, what you are touching at is extremely interesting. Is they are discussing about safe landing, safety zones. Safety zones, that's the term. Safety zones which are declared in the Artemis Accord. Funnily, that thing is not. They are not dimensioned right now. Might it be 1 kilometer? Might it be 10 kilometer? It will be. I think it will be something in between both of them. And just to put that into a picture, you can remember I showed the graphic with the South Pole. I'm not sure, I didn't mention it, but maybe you have seen that has approximately the size of Paris.
Yeah.
Of a big city. Now, if you start making little circles there of 5 kilometer or whatever, you will very quickly find out that this place will be extremely crowded. Because what you are just mentioning is exactly the reason for these safety zones. If you have an habitat somewhere here, you don't want your funny Chinese rover landing right next to it, 5 meters away, and destroying it. Either because there's an uncertainty in the landing, or because it's blowing up a lot of little particles that are not nice to your equipment. So I think that the effect that you are just described is not a problem if we are in this range of 10, 20 kilometer. I don't think it will fly so far. It will be an issue if it's closer. That's also sometimes what I'm criticizing. Well, I put it a little bit on my own slides too, but when you see lots of habitats very close to each other, how are they getting so close? Are you landing them somewhere and bringing them there? Okay, why not? But you're not certainly landing one next to another. I mean, anybody who is working a little bit in landing system and things like that knows there's an uncertainty, and this uncertainty is beyond some meters. It's quite a distance, and if you are not very good, then you are landing one system directly on the other. So you have to take this into account. But you're totally right. Totally right.
I see. Thank you. I guess I will also just continue with my second question, because then I'm all done in a sense.
Yep.
So I was wondering, the Eurohab that you showed, it's like 6 meters in diameter, probably, like exflated then?
Yep.
Yeah, or 7 maybe. So I'm wondering, obviously for the two astronauts that are coming for the first human mission for the planned 6.5 days, this will be plenty of space. Also, like, to psychologically don't feel like too,
Yep.
pressed into the space and stuff. But if there is like more people coming in the future, or also more different nations, how is this expected to be in terms of size? Or would it be better to have like maybe at some point a second Eurohab, so that you can, well, have more space to the individual persons there as well? Or what's the limits currently?
Well, I have a good news and a bad news for you. Bad news, the size is much smaller now. It's 4 meters.
Okay.
And we have the prototype right now in CEA. We are spending our time in there. 4 meters is quite close. So it's even smaller than the 7 meters that you saw at the beginning with the big one. That was started before we had the time really to check all the data. Basically, what determined the size of the habitat is you have you have a weight per weighs a certain amount of kilogram. And can you still hear me?
Now I can hear you again, but
Yeah,
you were,
okay.
at least for me, you were close off.
I have a warning on my screen. So, and what I said is actually we need really to make sure that this mass of payload can fit into this robotic lander. That's why it's now not 7 meter, but 4 meter. Now the good news is that it's a secondary habitat. They will not use it for 6.5 days. For most of the days they will stay inside their fantastic SpaceX spaceship, where they have plenty of space and a lot of room and mini bar and whatever. Our thing is only the security tent, if I might say. You could, it's obviously not so funny, but you could even imagine a scenario where they don't use EuroHub. They go 30 kilometers away from their landing spot, and in 10-kilometer distance, it is there. It's standing there. And if there's a problem, if they have a problem with the spacesuit or the life support system, or a solar storm is coming, then they can go there. They don't even use it. So to be honest with you, from an architectural point of view, EuroHub inside will be horribly annoying, not very nice. We try to make it as good as possible, but we really try to make that thing feasible from a technological point of view, and that's where we have to spare any mass that we can get out of it. So it will be quite crunchy inside. It will be quite how I say in French, rustique.
I see. Thank you very much.
Sure.
That's actually a clever point, because that means you will not have a lot of radiation problems.
We will not solve the problem of radiation. As I showed before, there is a big issue, and I think nobody has a real solution how to protect astronauts out of that are working outside the Earth magnetosphere from radiation. Might it be in gateway? Might it be on the surface? The only way protecting from radiation is mass. You need a big amount of mass. Might it be some metal or even water? Water is very nice, of course. And what we implement, I didn't show that. You might have seen it a little bit on the pictures, some of the pictures. There's a core inside the middle of EuroHub, which we call the telephone booth. It was Jean-Jacques coming up with that term. And that core will be a zone where you are more protected against radiation. A little bit more. Better than nothing.
A safe haven.
A safe haven. Yeah.
It's interesting. Very interesting concept. So that means for how many people is it designed?
2.
2. And what's the maximum stay?
We consider in a nominal situation that a crew of 2 persons will stay around 2 days, and in an off nominal situation it can be a crew of 4 until almost 2 weeks, I think. But that is really only if there's a big problem where they have to take refuge in that thing. What we calculate in order to be as comfortable as possible is 2 persons, 2 days. It's like a tent on if you go to Mount Everest.
No, I think it's great. It's an emergency shelter. We have a few years ago have also tested and simulated an emergency shelter, but it was for EVA activities, not as a habitat. Peter, are you here?
Okay.
Okay, now I can hear you again. I have one more question, because you talked about sustainability at the beginning. I also have some doubts concerning the sustainability of the missions. Peter, we cannot hear you at the moment. Can anybody else hear him? Okay. He has left us for a moment. All right. I have one more question that I want to finish. And Daniel, would you like to ask the question?
Yeah, of course.
Okay, after mine. We wait for him until he comes back. It worked well at the beginning. Let's see. Is there any other questions?
No, not very good, to be honest. I'm not sure. Would you mind if
Peter, we have one more question. Okay, maybe I turn off my video as well.
Yes.
Can you hear me?
I can hear you. Yeah, now I can hear you.
Okay, perfectly. So now we talk black and white.
Yes.
Peter, let me finish the question that I started on sustainability. I do agree with you on your doubts for a sustainable or future-proof mission. May I ask you what you think is necessary at this stage to assure sustainable missions on the moon, from your point of view?
It's yeah, well, it's certainly that we have to reuse equipment. If each Artemis mission is coming with their own equipment and going back again, landing sites too far away, then it's a Apollo remake to my point of view. And that's, as I said, you can remember this blue graphic where I showed the different items that Europe can bring in. I think all of these elements might be helping to make it sustainable. Producing power on site, habitats, of course. ISRO. This is the kind of things that I would say make lunar missions sustainable. It's not exactly the same sustainable like you talk on Earth, of course. For me, sustainable is that you start building up something on the lunar surface, going slowly towards even maybe a permanent presence of humans on the lunar surface. But that's still very far away.
And one more question. Have you thought of standardization?
Yes. I give you one example, spacesuits. At the time where we started with EuroHub, which is some years ago already, there were not these new spacesuit concepts that you have seen maybe in the last month. And we are quite acquainted with the NASA spacesuit system that uses a suit port. That means you are docking with your suit onto something and you climb out from the rear backside. At some point we were discussing about that. We say, okay, should we build a suit port into our habitat? It might be much nicer than using an airlock. We would have a big gain with that. We did not do that because we think, and luckily, by the way, we didn't, because we think you don't know what the future spacesuits will be looking like. You might even need to give your habitat in an emergency situation to Chinese astronauts, and then they need to be able to use that. So it's going a little bit in the direction of standardization in the terms of that you trying to keep it as open as possible, that as many users as possible can use it. Another example is the docking station with robots. Right now we are working on a robotic system that can be used for different standards that are existing already for orbit refuel.
And how do you manage with the loss of air?
You have to provide it. As I said, there are two possibilities. Either each crew is coming with a certain amount of air that they are pumping into that thing. We recycle air, of course, CO2 scrubbing, but obviously we will lose air, we will lose gas, because every habitat in space is leaking. Whatever you do, it is always leaking a little bit. And of course, if you're talking about an airlock, then you have quite big leakage rates. So either one strategy is that astronauts bring enough air that we can keep that thing running, or the other possibility would be to do a robotic resupply, that you have robotic vehicles coming from time to time and pumping air back into the habitat.
Okay. We have one question from Daniel.
Hello, thank you for your presentation. My question is your design in some points inspired by a science fiction art, or is it strictly based on science and research? Because maybe I think it's good to have some visions to how can things look like, or of course the technical aspects are more important than the safety of the people.
Yeah,
the economic aspects.
I saw your question 2 minutes ago on this chat, and since then I'm thinking about it. It's a very good question. I'm maybe like many of you a big fan of science fiction and whatever you can find out there, but certainly we try to really remain as technical as possible in order to make sure the thing is feasible. And I do not say that we found the nicest design. By the way, it could be much nicer. We would need actually quite a lot of help from designers and architects to make it look nicer. Right now, it looks really like, okay, this is the thing how it can be done technically. Is that inspired by science fiction? Yeah, certainly. Inside, yes. Inside there are some items that are coming from, that are somehow inspired by some very well-known television series and things like that, without naming anything.
That's cool. Okay, thank you.
Daniel, do you have a science fiction film that inspires you?
Maybe, how is it called? Interception. It's really cool. Or Interstellar.
Yeah.
Peter, another question. You said we will have this super fancy lunar habitat. This sounded like a joke, because I don't think there will be a super fancy large lunar habitat very soon, right?
When I was referring to these more complex designs, do you mean?
Yes.
Yeah. I share your view. I fear it will take quite some long time before we can see something like that on the lunar surface, seeing how it's going now. And I don't want to sound too pessimistic. That's really not what I want to do. I believe that in the future there will be a lunar base, and there will be even people living permanently on the lunar surface. But where I am very allergic is when I hear out of people from the agency showing something like that and communicating something like that. And this is so far away. And I mean, you take the European agencies right now. There's no concrete development in this kind of field. I give you an example. There's right now an exhibition in Paris talking about lunar habitats. There's a very nice model of IHAB. That's very nice. But there's a room full of lunar surface habitation concepts. None of them seems to me to some extent feasible in the coming 50 years. And I think it is extremely damaging if this is shown to the public, because the public will see that and say, okay, why are we not doing this? But today, nobody is able, the habitat that I showed some minutes ago, nobody is able to build a buried habitat on the lunar surface, not even the Americans, not even the Chinese. But they are not claiming to do it. And that's what I find so damaging today. It's damaging in many senses. It's damaging because you give a totally wrong image of what could be done with the means that we have available. And obviously, and here I speak as a startup, it gives a horribly bad image for a startup that is coming, if I might say, with this annoying habitat that looks so unfancy. In terms of investors and things like that, we have a real hard time because they say, yeah, why should we build something like that if we can build this fantastic, nice buried habitat with greenhouses and seven modules only for crew and things like that. But that cannot be done. Cannot be done. And yeah, agencies shouldn't make science fiction. They shouldn't do that. They should talk really about facts.
Okay. That's right. They should say at least what is left out. And what you said earlier is radiation shielding is left out in most of concepts.
Yeah.
Seen
Yeah.
what passed today.
And there's no real solution to this. By the way, at the beginning we were thinking about or considering or thinking about what it would take to bury EuroHub under regolith. It was the big version at the beginning, so 7-meter diameter, 7-meter height. And one of my colleagues sat down for some time and calculated the amount of regolith that would have need to be moved around. This is just enormous. You need a caterpillar for doing that. And there's no caterpillar on the lunar surface.
But I think what you said is, I mean, what you told us that you have this core in the middle, this onion radiation protection concept is a nice image for your habitat because it looks somehow like an onion.
Yeah.
And it is what it is, right? You have protection, and the further you go inside, the more you are protected. I think this is also a viable concept.
Exactly.
It is used on Earth in a similar way in traditional architecture for heating, for example, in cold areas. You don't heat all the rooms the same.
Yeah, exactly. Right.
So I think this is quite clever.
Mm.
And also you can predict solar particle events at least. And you will not stay longer than the Apollo missions. They also survived.
Yeah, it's just short missions.
Okay, I think we are almost at the end. Is there any other question left from the students? If not, then I would like to thank you very much, Peter. I think this presentation was very clear, very informative, and lots of details that are useful for architects.
Thank you very much.
And thank you very much for sharing that.
Yeah.
With all of us, that's very important because that information is not easily found.
By the way, I will send you the presentation in PowerPoint, and you feel free to
Wonderful.
give it to the students. And if you have questions, feel free to come back. By the way, it's you can send me an email. Thank
you very much, Peter. And we wish you success. See you on the moon.
Thank you very much.
Thank you.
Okay.
Thank you.
Danke. Ciao, ciao.
Ciao, ciao. Danke.